This interview is for information only and should not be considered as investment advice or a recommendation to buy shares in the company featured. Welcome to this Stock Box interview. Joining us today is Rick Mazer, the President and CEO of Forum Energy Metals, and Ken Wheatley, the Vice President of Exploration for FMC. So hello to you both. Today we're doing a special feature on uranium. So Rick, first of all, how are you? It's been a little while since we've spoken. How are things going generally with Forum?
Yeah, well, things are going great for Forum in its projects. Can't say that for the market, but we march on, we persevere.
Yes, indeed, the markets, well, it is the summer. That usually does happen around this time. I was talking to Ken just before we came on air, and it does usually happen around this time. It's probably particularly bad this year due to all the extra money that's been pumped into the system, and of course the COVID, people going on holiday, but it will come back. So Ken, how are you doing? Vice President of Exploration, how are things going?
Well, like I say, we're keeping busy here with planning with the upcoming projects, and then getting assessment reports done from what we've been doing over the last year, and getting those out of the way. So it's we're keeping busy.
Keeping busy. Well, that's good. That's good to hear. So, of course, we're going to be talking about the uranium projects with a focus on the Wollaston project, where, of course, you had some significant recent news about the recent exploration there and encountering mineralization at the project. But before we get into that, and Ken, you're going to take us through some slides. Rick, I wonder if I can just get a paragraph or two from you, just generally on how things have been progressing with Forum, but also the uranium market in general. Of course, the stock market is down, but how's the uranium market been performing?
Well, let me kick off with this. How are we going to get to net zero 2050? This is Bill Gates' book, How to Avoid a Climate Disaster. And I'm just going to read something from his paragraph on making carbon-free electricity and his discussion under nuclear. Here's the one-sentence case for nuclear power. It's the only carbon-free energy source that can reliably deliver power day and night through every season, almost anywhere on Earth, that has been proven to work on a large scale. No other clean energy source even comes close to what nuclear already provides today. So I think people are starting to accept the fact that nuclear energy is the answer. We're seeing that in the media every day. We're starting to see that in the uranium markets as well. I think we're seeing term contracts being signed by utilities because they're getting nervous. There's no above ground uranium left to buy cheaply. So term contracts are being signed by utilities. You got conservative companies like Cameco that are reopening their mines. The McArthur River mine is being reopened, so that's a signal of a supply crunch that's happening right now. And then you've got this whole Russian invasion of the Ukraine, and that has thrown a real wrench into the uranium markets, because 40% of enriched uranium comes from Russia. So that's going to put a lot of pressure on utilities. They need enriched uranium for their fuel, and I think the in the interim, what's going to happen is that the other 60% of enriched uranium that is coming from the Western world will result in overfeeding, which I won't get into the details of it, but overfeeding is they need more uranium to have better recoveries of enriched fuel. So it's going to create even more of a demand for a U3O8 for uranium fuel. So there's a lot of very interesting factors that are all coming together now, and I see a really bright future for the uranium market.
Okay, excellent. Well, that paints the picture quite nicely there going forward. Hopefully that all does time with the general cyclical nature of the junior and the commodities space. And we could be up for, well, the green shift, is going to be pretty significant when it kicks off. I heard a quote where we've got to create the investment of 6 United States within the next 30 years if we're going to go down this green shift, which calls for an awful lot of green energy metals. But of course, we have to fill the gap as well, like you say, for energy. And maybe this winter, when you see the headlines already warning us that possible energy rationing and blackouts, I saw that Switzerland was already prepping their citizens for possible energy blackouts due to not having enough gas or ability to power. Then maybe the world will wake up to the true potential of uranium there.
Absolutely, well said. Well put.
So thank you for that little update. So Ken, let's come to you then, and let's have a look at the project then. Of course, the big uranium project. Maybe I see you've got a slide there. That's the exploration update, but maybe just for the first minute or two, if you can, an overview of the project in general, what it's all about.
Well, we're going to cover 2 projects today, the Wollaston one that we've just released some news on, and then our Northwest Athabasca, which is up in the northwest side of the Athabasca Basin, where we're planning a fairly large drill program this winter. So Wollaston itself is just about 10 kilometers south of Rabbit Lake, the Rabbit Lake mine complex of Cameco, and about 25 kilometers to the south of McLean Lake, which is operating right now and run by Orano. So it's a relatively new project of ours that we picked up from another small uranium junior that let the ground lapse. It's got access. The road runs right through the property that runs to Rabbit Lake and points north. And it's got a number of nice conductors on it. It has been historically drilled in the past, but again, with the new techniques that we're coming up with, and especially using gravity, the gravity picks out areas of alteration that have not been identified before. So we've got a good series of conductors running through here, conductors with bands or have cross-cutting features on it. And in these areas, we've identified a number of places that have gravity lows at these spots that would be a good target to begin with. We now have a gravity low backing up the target definition. So this is where we're going to be doing most of our work is in these target areas. And this winter we mainly covered one gravity target, the Gizmo, and it's come back with some very nice alteration, and some weak mineralization has shown up. And we do have a conductor further to the north that we have to investigate. So we need to go back and take a look at this, and then take a look at a few other target areas further to the south on Wollaston. So nice project. We've just sort of scratched the surface on our very first drill program, and we have come back with some nice alteration and some weak mineralization showing up.
Good. And is it unusual to get good results on the first program? Does it come down to luck?
It's I've had some varied success over the past where I drilled the first hole into 7 meters at 7%. And then there's other projects where it takes up to almost 200 holes where you actually hit a deposit. MacArthur and Sioux and various deposits that took a lot of work to get these to find them. So it's variable. So getting some good sniffs like this in the very first drill program is it's a very good sign. But it's also showing that the techniques that we've developed over the years are now working quite nicely. Mm-hmm. And like I said, the gravity works well for us just outside the basin. The deeper you go into the basin, the fuzzier the gravity results become, because you have all the sandstone sitting atop, and sort of makes it not as clear. When you're just outside the basin and you're looking at basement hosted deposits only, the gravity is a very good tool for identifying areas of alteration.
Okay.
So we use this to some extent up at Northwest Athabasca, where we're going to go back to, and then again here at Wollaston.
Mm-hmm. Okay.
Okay, so I assume I can move on to the next slide here.
Yes, please. Yeah.
Okay. So this is a sort of a close-up of the Wollaston area, and you can see it's right on the east side of the basin, just south of McLean and Rabbit Lake. And here we have on the left side, we're showing all the conductors in the black outlines. The claims are also in black. And then we've got what we're covering with gravity is in green. And then the gizmo area that we drilled is in the red ellipse. And then we have all these black dots are old drill holes. And, but again, a lot of them were not necessarily in the right area, or they weren't on gravity lows. You can see the gizmo is completely untouched. And then we have a number of bends in here that are basically very little drilling and or no drilling on the gravity target itself, right, and especially right in through here along in this system.
Mm-hmm. And you were getting your gravity signatures from the green area, you say?
Yes, that was the main area that we worked on. Again, it's the closest part to the Athabasca Basin. And as far as I'm concerned, the closer you are to the basin, the better your chances are of deposit. You're higher up in the sequence, not as far down.
Mm-hmm.
So we will be working our way further to the east, but right now concentrating on the west side of the project.
Okay. So
this is the gravity that we got on the west side. And the blues are gravity lows, the reds are gravity highs. But you can see right here in the gizmo, a very nice gravity low. And there's a conductor that sort of wraps around it. And then further to the south, we have some nice gravity lows that we want to get back into as well on the next drill program.
Okay.
So this winter, we popped in 5 holes at Gizmo, 1 at Mugger, and then 2 at Stripe. With varying results. Again, Gizmo by far kind of returning very nice alteration and the weak mineralization in through here. The Mugger was more of, I think, lithology that was showing there, and Stripe had some alteration, but again, not as good as that Gizmo. We would go back to Gizmo for sure.
Mm-hmm.
The next drill program.
And just on the gravity, what is the what is it suggesting then? Is it suggesting something heavy is there? Is that what it's suggesting?
No, it's actually light.
Light. Okay.
Yeah, it's the alteration. Basically, the basement rocks have been hydrothermally altered, and it takes out a lot of the material out of it. So what would normally be about a 2.6 specific gravity can go down to about 2.2, even a 2.0 specific gravity. So it's quite a bit lighter than the surrounding rocks, and that's due to a lot of clay and water in the area instead of nice hard, typically metamorphic basement rocks.
Okay, so and that is where the uranium would leach into potentially. Is that right?
Yes, I think originally the gravity was done in hopes that we would be fine, because the uranium is so dense that people thought, okay, we're going to get a gravity high because of the,
yeah.
But these deposits are so small. They're also very high grade, but they're also very small. But within the size of the alteration halo that surrounds it, you actually get a gravity low rather than a gravity high. And I suppose if you did a 1 meter spacing, you might pick up the small mineralization itself. But we're running at about 50 to 100 meters. We take a sample every gravity station every 100 meters square. And it's all the dots on this screen right here, on the big screen, those are the gravity stations where they took a reading. And it shows up this gravity low quite nicely here.
Okay, I see. And that gravity low is, as you say, it's a wet area, very clayey.
It's clay rich in the basement rocks. I have some photos of the core.
Okay.
To show what it looks like and why it's showing up here.
Mm-hmm. Okay.
And actually, there's some of the alteration itself. So you can see the orangey material is what's left of the granitoids. You have chunks of granitoid in here, and then the rest is bluey gray material it's clay. So quite a light density. And this is due to the alteration of the hydrofluids that have come through here.
Mm-hmm. Okay. And the uranium would be just in the mix of these cores?
That's right. It's usually in the middle or along some kind of structure where the fluids would have been flowing along, and then the uranium comes precipitating out due to a reductant or a release in pressure, oxygen fugacity. There's a whole bunch of different reasons why the uranium would come out. Yeah. There's probably a mixed bag of things as to why it would come out in these areas, but this is what we want to see is zones of this alteration, because then we know the hydrothermal fluids have moved through here. And again, what you want to see within this is something like this showing up. And here you have, you got the yellow oxides, the uranium oxide showing up. This is a little bits of pitch blende with the alteration around it and the nice hydrothermal hematite. And again, over here, you get little bits of coffinite pitch blende showing up with these reaction rims. So this is what's showing up in the core, which is getting us all excited within that big alteration zone. Mm-hmm. So it's our job now is to figure out, well, where's the high grade? And
because I seem to remember from our when we talked previously on a podcast where you were telling me about how uranium is deposited. It's moved, it's sort of leached, isn't it, from one place to another, and you kind of have to follow and see where it's at the moment. Is that right? Where it's kind of settled?
That's correct. That's like a lot of deposits. You have gold or base metals. It's been leached out of an area that has, weaker amounts of nickel, gold, uranium, whatever it is. And it's brought along and concentrated and then dropped off in one spot. And that's where the concentration takes place and becomes a deposit. So it's, with these fluids that were moving the uranium around, they're about 200 degrees Celsius and about up to 20% salt, so very caustic. Just imagine what that would do to your car, It wouldn't last long. So anyway, it's picked up the uranium, leached it out of the surrounding rocks along its whole route underneath the Athabasca Basin, concentrated along these conductive zones, because conductors tend to be fault zones and allow the fluids to move through them. And then wherever you have a bend in the conductor or cross-cutting fault, this area sort of opens up and allows this uranium to precipitate out into one certain spot.
Mm-hmm. Mm-hmm. Okay. So when you look at core like this, then that's telling you things are looking positive. You've not only got uranium within part of the core, but you can see that hydrothermals have been through here. So it forms the next part of the exploration, does it, to try and follow the path?
That is correct. We got to take a look at this, get a little more drilling done in this area. We're planning an airborne EM survey over the entire project to help us be a little more exact with our conductors. We've been using so far historic EM conductors that have been done in the past, but again, they've been different systems used at different times. So what we want is that one complete EM system over the entire project that makes it very consistent. And with the GPS information that we have, it'll be very exact as well, and it'll help a lot with our targeting, along with the gravity that we've done here.
Okay. Thank you.
I think we've got so here it is. Here, this is the mag in the background, and then the red lines are the conductive systems that we're doing gravity along. And this purple outline is where we're going to be doing the airborne EM to pick up, to update all the EM conductors in the property.
Okay, so that'll be flown by helicopter, like it says there. You go over and take EM readings.
That's correct. It's going to be flown probably at the end of July. We'll be having that that area flown.
Excellent. Okay. And then this will end the program for this year. And then is it planning? Then is it for the next exploration program?
Yes, it'll be once we get that information, we'll put it all together, and then we can plan the next drill program, and possibly some more gravity along these conductive systems.
Okay. So is that everything on Wollaston?
Yeah, one more slide, I think it is. And this is the gravity, once again, showing, 3 different target areas on the west side that we want to go back to. So get back to Gizmo and then take a look at the conductive systems within these gravity lows, and that'll be our good targets for the next drill program.
Okay. And that next drill program will be next season, effectively. So,
in theory, it's up to Rick's job to get the money for it, and off we go.
yeah, okay. Okay, good. But from your point of view, then, from the vice president of exploration, and you're a geologist, what's your initial reaction to this then, as an early sign at the project?
Well, it's quite exciting. Again, the location of the project, the number of conductors we have on it, these nice gravity lows showing up, and like I say, the very first target coming back with some mineralization. It is a very prolific area. There's a lot of mines in this part of the Athabasca Basin in the northeast part. So there's good potential here for mineralization to be of economic grade on this property. Okay. And again, with two mills sitting there, especially the Orano McLean Lake Mill, they're looking into the future with Cigar Lake possibly running out in about 10 years. They have to have feed from somewhere, and this would be a very nice spot just to be able to drive the ore from.
Okay, and it is, of course, this is the first drill program, so it's too early to say what really is going on. But in the RNS, I notice it says up to 0.21% uranium. Can you put that into perspective for people who are perhaps not familiar with uranium grades?
Well, that's anywhere else in the world that'd be economic grades, but the Athabasca, the Athabasca is a funny place in that it's got the highest grades in the world of any uranium deposits. So a lot of them are anywhere averaging from 2% and up for these deposits. Myself, I have pulled up to 50 centimeters of up to 88% uranium out of the Sioux C deposit. So you get very high grades here. But again, if you're on the periphery, finding boron, elevated nickel, cobalt, copper, and then again, of course, up to 2.2% uranium is a very good sign that mineralized fluids have moved in the area too.
So you get very high grade, but did you say also a small deposit? So you're not going to get a huge deposit necessarily, but you're going to get high grade?
Yeah, the two bigger ones, MacArthur and Cigar Lake, are in the 400, 500, 600 million pound range. Long and skinny, and especially when you're drilling down on top, they're hard to find because they have a very limited footprint. But again, the grades are, can be quite spectacular compared to everywhere else in the world. The roll fronts, you have these big, huge areas, but you're running, if you're lucky, 0.1%. They get a lot of it moved out or dissolved to be able to mine it. Here, again, very small, so they're tough to find, but when you do hit them, it's certainly worth it because you just have a small area to mine out with some very high grades.
Excellent. Okay. And what about the other credits that you mentioned there, and it says in the RNS about nickel, copper, and cobalt? Would that be something that excites Forum or not necessarily?
It would be a byproduct, especially cobalt is looking quite, interesting nowadays. But it wouldn't be at economic grades on its own. But if you find a deposit, it would be something you could put into the circuit to extract and add value to the ore.
Okay, excellent. Okay, so does that cover Wollaston then? You've got talking to us about the Northwest Athabasca as well.
Yes. Okay. There's the conductors. So Northwest Athabasca is, we've worked there back in about 2012 to about 2015, and it's been on hold mainly because of its location up in the northwest part of the Athabasca Basin. But it's, again, a very fertile area. There's a small deposit, 1.5 million pounds there. And then when we started exploration, again, the first thing we did was a gravity survey, and 3 out of the 4 gravity lows that we tested came back with mineralization in it. So there's and then there's some high grade holes that we're hitting here as well from the past and some of our own. It's quite an interesting project. And we've been working mainly in this part of the area, if you see my mouse, and this would be Opie, and we're working our way further away from the known mineralization. So we have a couple of targets here and a very large gravity target at Spring Bay that I want to get into to take a look at in 2022 or 2023.
Mm-hmm. Mm-hmm.
So what we're planning to do, because we have to get across the ice, what we don't want to do is wait and see if it's going to be a good year for ice to get everything in there. So we're going to barge it in the fall and have everything set up and ready to go early January. And that way that we won't be delayed by any weather conditions.
Mm-hmm.
We'll be able to just get to drilling right off the bat.
Was that the problem with the last round of drilling, that the weather wasn't favorable to get the gear in?
Yeah, there's a number of times we've had issues with the ice. We have to wait for an ice road to be opened up to Uranium City. And from there, we make our own ice road across. And if it's lousy ice or too much snow or whatever it is, it causes delays in the program. We can't get a big program done. So we're doing a preemptive strike here, getting the camp set up. The drill is already on site. We have to get the fuel in, have everything ready to go for January 2nd. And we should easily get our 5,000 meters in.
Excellent. Okay, it's early planning. Yeah, really getting it all in now before January. Okay, excellent.
Okay, now it's sort of funny about that. But you take a look at the big picture here, the Athabasca Basin, which is the black outline, and there's sort of a dividing line that runs through here, and every deposit on this side of that dividing line is orientated in the northeast direction. And you get across that line, and then the deposits at Cluff Lake, Shea Creek, Maybell, and we have some nice structures in that direction that are orientated to the northwest. So I'm going to be concentrating with the Andy target right here on these structures. And we have a lot of structures that run across sort of an east-west. We've hit mineralization with them, but it was weaker mineralization. On the northwest structures, for example, Zone 1A and Zone 2A, we've historically they've been up to 8.5 meters at 5.5%, which are pretty spectacular grades. And that would be right in here. And then our gravity target, Andy, is right here. The conductive system runs right through Andy. We have a nice gravity low that's untested, completely untested. And I do believe we have. Okay, so these are gravity targets that are mineralized that Forum has found, that were not found before, and now we're going to be going up to Andy next. And what also is present are these big boulder fields of radioactive rocks that we have scattered about the place. So this boulder field would have come from the deposit, the Morris Bay deposit, and then this would have come from probably the Opie area. Now, Andy's right here, and then there's a nice boulder field over here that's probably down ice from the Andy area. So it's quite a good target. That it's gravity low, it's on a conductor. There's known high-grade mineralization just on the same conductor to the south of it or close to it. And we also have the contact between basement rocks and sandstone rocks right in this area. So very interesting target. Spring Point. Again, huge gravity low up here. It's the largest gravity low on the property. And again, boulders, radioactive boulders along the shoreline through here. Historic drilling was done right along the edge here, but they didn't know about the gravity low out here. So again, it's basically untouched. And I say it's our largest gravity low on the project that I want to get drilled. So those are the two main areas we're going to be drilling this winter coming up.
Okay, so you're taking the same approach, using the gravity low as an indicator of where to start and effectively going for it and seeing what you find.
That's correct. Get a few drill holes into it, and again, using the EM that's already present. Spring Bay is so large, we'll have to be careful where we're drilling right dead center to see if we can find the mineralization. Andy's a bit smaller, easier target because we'll have the basement sandstone contact to work with, along with the EM conductor within the middle of the gravity low. So anyway, it should be a very interesting program this winter.
Yes, indeed. I'm sure you're quite excited to get going. And the gravity low, this is new technology, presumably, that wasn't available. That is why in the past this area just wasn't drilled at all, purely because they didn't have the I don't know, the lead, if you like, the clue from using technology such as this.
Yeah, gravity's been around for quite a while, but it's certainly the methods that they use now are so much better.
Okay.
The machines are much more precise or much more sensitive that they're picking out these areas that would not have been picked out before, or they would have been difficult to pick out before.
Mm-hmm.
And again, we've been using this up in the Arctic in our Nunavut projects, and it's shown that it worked up there. So we decided to try it in here, and we had, I think it was 17 targets showed up when we did our first survey, and we just, it was almost too many to work with. So we worked our way out from known mineralization on these gravity targets, and they say we hit 3 gravity targets that were mineralized, 1%. And now we're just going to go a little further afield on a very large gravity low to see what works. But again, with the introduction of GPS, making it much more exact, and the sensitivity of the machines makes it a very good survey to work in these areas now.
And is this the first program that Forum will do on this project?
No, we've, like I said, we drilled back 2013 and 2014, I think 2015, and this is where we found these other mineralized zones. But it's been sitting there.
2015 was when the uranium market got really, really tough, and essentially there was no funding available. I mean, we would have kept going at Maurice Bay here if financing was available, but it was just really a tough time.
Okay, so it's the first program for a few years.
Yeah, but 7 years now, 7 or 8 years it's been since we've drilled here. So it's
Okay, excellent. Okay, do you have any more for us, Ken? Or
yeah, I think this is the last slide and sort of a close-up of your conductive systems running down through here. Andy's right on the conductive system. There's the zone 2A with the nice 5 millimeters at 8.5%. Another parallel conductive zone runs along through here, and this is the geology map. And you can see, the sandstone is just wiggling back and forth, following these structures, sort of like a graben structure right through here. And the Andy, there's your zone 2A with the mineralization, and the Andy lies right along through here at this contact. So again, very interesting area that we're going to be getting some holes into for Andy. And then of course, Spring Bay is the monster off in the lake. So
okay.
And could you point out, Ken, where the Maurice Bay deposit is there too?
Yeah, in red is where Maurice Bay mineralization is all through in through here. And then you get zones Maurice Creek, and then again we have our Opie in through here, and Otis. We got a couple more zones of mineralization in here that we hit down in the basement. And again, back when in the 70s, early 80s, when this is originally drilled, they would drill through the sandstone to the basement and then stop the hole, because they didn't realize at the time that you could have a mineralization down into the basement. So to save money, as soon as you hit that unconformity, you stop the drill program. And we actually found basement hosted mineralization right underneath where they drilled historically, and stopped the holes short, just underneath the unconformity.
Okay.
So it's progress. As years go by, our understanding of uranium deposits gets better. In another 20 years, 30 years, they'll be looking at what we drilled and go, oh, why did they stop there?
Yeah.
It's just what happens. And with new techniques and new understanding, it develops better targets in these areas. But this is such a prolific and fertile area. I'm quite excited about this one to get back into here and get some more drill holes in here.
Good stuff. Well, thank you so much for laying out that drill program there for Northwest Athabasca. And you're getting all the gear moved in, the barge is getting all the kit and the camp set up ready for January. So yeah, I'm sure when we come back in the new year, after we've gone through the summer and the business year started again in September, October, the market can look forward to seeing how that drill program is going. And then just quickly, just summarising on Wollaston then. So that program is now complete, and what's the plan to assess what you've got and devise a new exploration plan? Is that right? And how are things going?
Well, like I say, we've got the airborne survey planned
Yeah.
for end of July, and then once that's done, it's getting organized for the next drill program. What targets we're gonna drill, and that's based on how much money Rick can raise, and away we go.
Excellent. Okay, well, let's come back to Rick then. Rick, it's up to you to get the funds to continue the exploration here.
Yeah.
Maybe just a few final words from you about how you're feeling about these projects and the plans, you know, that they're sort of looking forward for the company.
Mark, both these projects are really prolific areas of the Athabasca Basin. Wollaston is right next door to two existing uranium mills, very well located. Ken's first drill program at Wollaston got uranium mineralization and all the right alteration that you're looking for. Great start to that program. And then Northwest Athabasca has an existing deposit of 1.5 million pounds. We've had 3 drill campaigns on that before, and Ken's got some very, very good intercepts from past drilling. Unfortunately, and we had to stop that in 2015 when things got tough to finance. But here we are back again in a good uranium market, and we hope to finish the job by making a big discovery out on our Northwest Athabasca joint venture project as well.
Excellent. Okay. Well, thank you both very much for your time. Of course, Ken Wheatley, the Vice President of Exploration, for explaining all about the exploration that's been going on at Wollaston and Northwest Athabasca. Good luck with everything that's coming up with the exploration there. And Rick Mazer, the President and CEO of Forum Energy Metals. Thank you both very much for your time.
Yeah, thank you.
Thanks, Mark.
If you enjoyed this interview, then give us a thumbs up, a like or a retweet. Subscribe to us on YouTube or follow us on Twitter and hit that notification bell to be the first to know when we release new content. There's loads of great content on our website too, across all our programs at stopboxmedia.com. Thank you for watching.